Hello and welcome. In this video, we're going to be looking at an integration technique called trig substitution integration. At the end of the day, this trig substitution, this is a substitution. So we have an integral that is difficult to integrate, and we will use some type of substitution to make it easier and simpler. So let's see the cases where we use trig substitution. First one is when we have something that looks like this. A squared minus x squared dx. Second case, so this is one. Second case is when we have square root of a squared plus x squared dx. And the third case is when we have square root of x squared minus a squared dx. In the first case, when we have something like this, we should substitute x with a sine theta. Why is that? Because at the end of the day, if x is a sine theta, this is going to be a squared sine squared theta. When you take a out common, you will still have something that is 1 minus sine squared theta. And we know from trigonometry, 1 minus sine squared theta is cosine theta. So now we changed into this substitution, and I will show you how this works when we solve questions. The second part, when you see something that looks like this, you should substitute a tan x equals a tan theta. And why is that? Because we know 1 plus tan squared theta is secant squared theta. And over here, when we see something like this, we should substitute x with a secant theta, because we know that when we have secant squared theta minus 1, that is tan squared theta. So let's take a look at how this works using examples. So our first example over here tells me that I have an integral that looks like this. Square root of 9 squared minus x squared over x squared dx. How do I do this integral? So first of all, which of the three scenarios does this look like? This looks like scenario 1. Okay, so a squared is basically 9. This is 9, not 9 squared. So a squared is basically 9 minus x squared. So I have this kind of expression over here. So which substitution should I do? I should do the first one, so a sine theta. So over here, x should equal, if 9 squared, if 9 is equal to a squared, okay, then a is equal to square root of 9, so a is 3, right? So a is basically 3. So a sine theta, so a, which is 3, times sine theta, okay? That's the first step, knowing which substitution you should do. Second step is we should differentiate this. So let's try to differentiate dx by d theta. This is going to equal, we know that the differentiation of sine is basically cosine theta. That makes my dx, I can multiply both sides by d theta. So that makes my dx 3 cosine theta d theta. Let's now substitute everything. So I'll have a square root, an integral of square root 9 minus x squared. Okay, what is x? It's 3 sine theta, and that is squared. Over x squared again. So what is x? It's 3 sine theta, all squared. And what is dx? dx is 3 cosine theta d theta. Okay, let's try and simplify from here. Because this is the integration of square root of 9 minus squaring the 3 is 9, squaring the sine theta is sine squared theta, over again 9 sine squared theta times 3 cosine theta d theta. So over here, what I can do is, I can, from this expression, I can take a 9 out common. So this becomes integration of square root of, I'll take a 9 out common. 9 divide 9 is basically 1 minus 9 sine squared theta divide 9 is basically sine squared theta. And this is the whole point. We want to reach to this because we know that this substitutes to cosine squared theta. This is over 9 sine squared theta times 3 cosine theta d theta. So over here, what I can do is I can square root this 9, so it becomes integral of 3 times 1 minus sine squared is basically cosine squared theta over 9 sine squared theta times 3 cosine theta d theta. Over here, 3 times 3 is 9. I have a 9 on top and a 9 on bottom. I can cancel everything. And this is going to be, okay, this is under the square root because only the 9 came out of the square root and became a 3. This is under the square root. So we have integration of square root of cosine squared is basically cosine theta, and then I have another cosine theta here, so when I multiply them together it becomes cosine squared theta over sine squared theta, and this is what I have till now. Okay, so what we should do is we should try to change this cosine squared theta into 1 minus sine squared theta. So this is equal to 1 minus sine squared theta over sine squared theta, theta, and I'll split this fraction into 1 over sine squared theta minus sine squared theta over sine squared theta is basically 1. All of this with respect to d theta. And over here, I know that 1 over sine squared is basically cosecant squared because 1 over sine is cosecant. So this is integration of cosecant squared theta minus 1 d theta. And I know that integration, or no, I know that the differentiation of cotangent theta equals negative cosecant squared theta. So the integration of cosecant squared theta is going to give me negative cotangent theta, and the integration of minus 1 becomes minus theta plus c. So now the integration is done. However, it's in terms of theta. We need to bring it back to x. So let's go back to the original substitution, which said that x equals 3 sine theta. From here, I can say that sine theta equals x over 3, right? And if I have a right angle triangle with theta equaling x over 3, I need to know from so, ka, toa, okay, and I have a full playlist on trigonometry, which will help you a lot, especially in all those identities we're talking about. I'll leave a link to it on the top right hand corner. We know that sine is opposite over hypotenuse, so that tells me that this is the opposite, this is hypotenuse, so x over 3. And using Pythagoras, I know that since this is a right angle, I know that a squared plus b squared equals hypotenuse squared, right? So x squared, which is this side, plus this side, let's call it s, plus s squared equals 3 squared, which is 9. So if I want this side, it's basically s equals to 9 minus x squared. This is s squared. If I want s, I'll just square root both sides. So s, or this missing side, is basically square root of 9 minus x squared. So why did I do all that? Because this is going to help me in getting what is this cotangent. I know that cotangent theta is equal to 1 over tan theta, right? And from here, I know that from toa, tan theta is equal to opposite, which is x, over adjacent, which is square root of 9 minus x squared. So cotangent is 1 over that. So cotangent theta is going to equal square root of 9. So I'll basically flip that over x. So this is cotangent theta. And so this is this part. I can substitute it. And the theta itself, I can take a look at this sine, okay, and I can take arc sine of both sides. So arc sine of sine theta equals arc sine x over 3, So arc sine of sine theta, that's basically theta, which is going to equal arc sine x over 3, or basically sine inverse of x over 3. So cotangent is square root. Let's copy this. So my final answer was negative cotangent minus theta. Instead of cotangent, I'm going to put square root of 9 minus x squared over x minus, instead of theta, I'm going to put arc sine x over 3. So arc sine x over 3. And I cannot forget the constant of integration because this is an indefinite integration. And this is my answer to the first question. Let's take a look at another example. So let's try and get our rules from here. Okay, so let's do this example over here. Let's say we have the integration of 1 over x squared root x squared plus 4 dx. Okay, what situation does this look like? Is it situation 1, 2, or 3? This part is very similar to this part, right? So this is a scenario where we use x equals a tan theta. Okay, so we should substitute x equals a tan theta. So over here, this is a squared. So a squared is equal to 4. That makes a equal to 2. So x is going to equal a, which is 2, times tan theta. And the second step is to differentiate that. So dx by d theta is equal to, we know that the differentiation of tan is basically secant squared theta. So this is going to be 2 secant squared theta, making my dx, I'm just going to multiply d theta both sides. So this is my dx right now, and I'm ready to substitute everything. So this is going to be the integration of 1 over x squared. What is x squared? It's basically 2 tan theta squared. So 2 squared is 4 tan squared theta times the square root of, again, x squared, which is 4 tan squared theta plus 4 times dx. What is dx? It's 2 secant squared theta d theta. So over here, this I can do some simplifications. First of all, I'm going to divide this by this. This is a 2. This is integration of 1 over 2 tangent squared theta, square root of, taking 4 common, this is going to leave me with tan squared theta plus 4 divided 4 is basically 1. And on the top, I'm going to have a secant squared theta d theta. Over here, what is tan squared theta plus 1? I know that this is basically secant squared of theta. So this could be written as secant squared theta d theta over 2 tan squared theta. Square root of 4, I'm going to put this 4 outside. So I'm going to multiply by a 2. So it becomes a 2. And then what's inside is square root of tan squared theta plus 1, which is square root of secant squared theta, right? Over here, I know that this will cancel with the square. I will just have a secant theta in the bottom. 1 secant theta, divide one of those. I'm going to have a secant theta d theta on top over 2. 2 times 2 is now 4 tan squared of theta. So this is my integral now. So what can I do here? From here, what can I do is change every secant and every tan and everything to sines and cosines. So I know that secant theta is equal to 1 over cosine theta. So this is going to equal 1 over cosine theta multiply 1 over 4 tan squared theta. Isn't that correct? And instead of tan squared theta, I know that tan is basically sine over cosine, all squared, right? So this is equal to 1 over cosine theta times 1 over 4 sine squared theta, and this cosine squared theta is gonna go on top cosine squared theta, like this, d theta. This is all integration with respect to d theta. So from here, what I can do is I can divide those two. So this becomes integration of 1 over, no, this becomes a cosine theta on the top, 4 sine squared theta d theta. This is what I reached over here. So what I can do from here, I can quickly notice that I can solve this part using u substitution. By the way, when I have something like this, so 1 over sine over cosine, this is similar to 1 divide sine over cosine, which is the same as 1 multiply cosine theta over sine theta. That's why the cosine, which was here, jumped to the top, because as we can see, it's on the top. That's why this cosine came here. Okay, so this integration now, this is what I have. I can see that this could be solved using a u substitution. How? I know that if I made u equal to sine theta, my du by d theta is going to equal cosine theta. And I have a cosine theta here, so that is perfect. So I know that du is going to equal cosine theta d theta, right? So I can rewrite this as integration of, okay, cosine theta times d theta is basically du. So this becomes du over 4. Sine theta is u, so sine squared theta is basically u to the power of 2. And now I can do the power rule. Normally this is similar to 1 over 4 integration of u to the power of negative 2 du. So adding 1 to the power, dividing by the new power, becomes 1 over 4 u power negative 1 over minus 1 plus c. So this is basically equal to negative 1 over 4 u plus c. So over here, I know that u is sine theta, so this is negative 1 over 4 sine theta plus c. So now this is my integration done. However, I cannot leave my question like this because it's in terms of theta and the original question was in terms of x. So I will return back to my original substitution, which was x equal to tan theta. Let's write it here, x equal to tan theta, making tan theta equals x over 2. We do our right angle triangle with this angle as theta. Tan from TOA is opposite over adjacent. So opposite is x, adjacent is 2. This is the hypotenuse, which is square root of x squared plus 2 squared, or basically 4. Over here, I know that sine theta is going to equal from so is opposite over hypotenuse. So sine theta is opposite, which is x over square root of x squared plus 4. So this becomes minus 1 over 4 times, instead of sine theta, it's now going to be opposite, which is x over square root of x squared plus 4. This is similar to what we've done. So this is equal to this square root of x squared plus 4 is going to jump to the numerator. So negative square root of x squared plus 4 over 4 times x plus c. And this over here is my final answer. Let's take a look at another question. So let's take a look at a third question. So question 3 looks something like this. So I have square root of x, no, this is integration of x over square root of x squared minus 7 dx. So how does this look like from our 3 scenarios? Okay, let me rewrite this. This is integration of square root x squared minus a squared. So this basically looks like this final one, because I have an x squared minus something, right? So this makes my a squared equal to 7, which makes my a equals to square root of 7, right? So now my substitution should be x equal a secant theta. So a is root 7 times secant theta. This is my substitution. So to get rid of this dx, the second step I should do straight away is just differentiate this. So dx by d theta is going to equal, okay, now what is the differentiation of secant theta? It's basically secant theta times tan theta. So this becomes root 7 secant theta tan theta. So over here, if I only want dx, I will multiply both sides by d theta, and this becomes my dx. Now I'm ready to substitute everything. So this is equal to integration of x, which is root 7 times secant theta, over square root of x squared. So it's root 7 secant theta all squared minus 7 times dx. What is dx? It's root 7 secant theta tan theta d theta. So over here, what I can do is first root 7 times root 7 becomes a 7. So this is integration of 7. Secant theta times secant theta becomes secant squared theta times tan theta d theta. And over here, I can distribute this power 2. So this becomes square root of 7 power 2 is basically 7. This is the, yes, so this is all under the square root. So this becomes 7 secant squared theta, because secant theta squared is secant squared theta minus 7. So this allows me to write this as taking a 7 out. So taking a 7 out of this, this becomes integration of theta d theta over square root. If I take a 7 out, it becomes secant squared theta minus 1, right? And over here, what is secant squared theta minus 1? I know that this is tangent squared theta. So this is equal to 7 secant squared theta tan theta over square root of 7. I'm gonna put it alone like this, and this is times square root of secant squared theta minus 1 is tan squared theta all d theta. Now I did my substitutions. Let's do the simplification, because the harder part is not only remembering the substitution, this is the easy part. The hardest part of this is doing simplification and doing basically integration of trigonometric functions. So, okay, first of all, this squared and the square root cancel. So I'll have a square root of 7 secant squared theta tan theta over root 7 tan theta. So over here, tan theta and tan theta cancel. 7 over root 7. This is basically, we know that if I have a over power m over a power n, this is equal to a power m minus n. So over here, this is 7 power 1 and this is 7 power half. So if I will use this, this is going to equal 7 over 1 minus half. So it's equal to 7 power half. So it's equal to root 7. So these two I can change with root 7 on top. So it's integration of root 7 secant squared theta, and that's it, d theta. Okay, so I know that the differentiation of tan theta is equal to secant squared theta. So the integration of secant squared theta is nothing but tan theta. So this is equal to root 7 tan theta plus c. Now I finished my integration. It's now time to just substitute the theta with the x. So let's go back to our original substitution, which was x equal root 7 secant theta. So x was equal to root 7 secant theta. That makes secant theta equal to x over root 7. Okay, what is secant theta? I know that secant theta is 1 over cosine. Secant theta is 1 over cosine theta. And this is equal to x over root 7. So over here, I can say that cosine theta is equal to the reciprocal of this. So it's root 7 over x. And now let's do our triangle, the right angle triangle, making this as theta. I know from SOHCAHTOA, ka means adjacent over hypotenuse. So the adjacent is root 7, hypotenuse is x. That, using Pythagoras, makes this side as x squared minus root 7 squared, which is basically just 7. Okay, now I'm ready to substitute this tan. So tan from TOA is opposite over hypotenuse. Yeah, so that makes tan equal opposite over adjacent. So opposite is root x squared minus 7 over adjacent, which is root 7. So this becomes root 7 times tan, which is opposite, square root of x squared minus 7 over adjacent, which is root 7 plus c. Root 7 and root 7 cancel, so my final answer is square root of x squared minus 7 plus c. This is the final answer to this question. So these are the basics and all the scenarios where you will use trig substitution. I hope this video was helpful. I'm going to be doing a more difficult trig substitution video. If you would like, please leave me a comment down below. Hope this video was helpful. Please don't forget to like, subscribe, and comment. Share the video. And till I see you again, thank you for watching.